Singularity, black holes, and Big Bang. So, now before we begin, I just want to ask you, do you know what's there in the center of a black hole? The center of a black hole is completely unknown to physicists today. So, what is inside a black hole? We don't know what exactly is inside a black hole, and we call it singularity. So singularity is the thing where all the laws of physics fail. It is impossible. There are many types of singularity. The main singularity in physics today is the gravitational singularity done by a black hole. So now, before we move on, how do we solve this singularity? Singularity is practically impossible to solve with all the current physics and mathematical laws, and that's why we're trying to make a thing called the theory of everything. The theory of everything might help us to solve the thing so-called singularity. Now, the gravitational singularity is a place it's also called as a space-time curvature singularity. So the thing is that here the space-time curvature practically goes to infinity, 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 and the normal rules of mathematics fail at the exact center. That is why it's named as singularity. For example, any number divided by 0 is not defined. Now, what does not define means? You must try to define it somehow. So, it is so tough to define it. And now, when we head on to a black hole, when we move towards the center of the black hole, let's move on to a black hole currently, as we have started talking about black hole. Now, what a black hole actually does is suppose you're a person here, and when you go towards the center, the gravity becomes much immense. So what happens is that your top part over here faces higher amount of gravitational force than your part here. So this part stretches like this, and you become from a body like this to a very thin body like this. And this is what is called spaghettification. Spaghettification. Sorry about that. Anyway, spaghettification. So what's the spaghettification? Just stretch it out and then just tear apart and fall into the center of the black hole. But now, the main singularity comes here. The problem with a black hole is, suppose this is the event horizon and you see an object falling into it. What you see is that you see that this object is continuously falling, but actually the object in its perspective has already gone inside the event horizon. But as the time becomes infinity, you just see the object still stuck there. And that is a very big problem. And that is what is another singularity. And all of this is gravitational singularity. Now, what you know is black hole is black, isn't it? So, but actually, we have found out that black hole is not exactly black. When particles move towards the singularity, the particles sometimes get flipped away as radiation, and this is called Hawking radiation. So, this Hawking radiation is not actually visible light, but the thing is that things can also escape from a black hole, and that is what Stephen Hawking said. Now, when we come to gravitational singularity, there is another type of singularity called initial singularity. Now, initial singularity is related to Big Bang, and you will know why. In the Big Bang, when it started off like a big explosion, from which mass continuously started expanding, and the four fundamental forces of physics: the strong force, the weak force, gravitational force, and the nuclear force was produced, and all the forces, sorry about that, all the forces was created, and mass and everything collided and the universe was formed. And also there was a war between matter and antimatter. So now the Big Bang, the time when the Big Bang was just a small spot, the space-time curvature was infinite. Infinite, and also the density of matter becomes infinitive, and the temperature was also infinitive. But the thing was, the space in it was zero, like a zero dimension, with no height, breadth, length, anything. It didn't have anything practically. Everything was just a blank space of matter. So now and also all the paths going to time was zero. Time had just come to an end. Can you believe that? And also, if you want to calculate the density of it, it's just infinitive by zero. And that is what a big singularity is about. Now, how do we solve all these types of singularity? According to me, like what I think is a black hole or all this type of singularity is a type of wormhole, or not actually a wormhole through dimensions, which means if we move towards the center of a black hole, what I think is that things just disappear, but it's not actually disappearance, it just travels through dimensions. So the thing is that what I think is black hole might be starting of another universe. Like before the Big Bang happened, we were living in a four-dimensional space, which is 5 dimension, and a black hole in that just died. So black hole created a space inside a space, and most probably, the thing what I believe is that all the black holes in our universe also might expand to create a two-dimensional space. That's right. But I haven't got full proof for this, but this is what according to me is, because it sounds a bit true, and that's what all I have got to say with singularity, Big Bang, and black holes. And we may be even able to time travel through black holes. And that is because, suppose if this is the event horizon, we are just looking in a 2D perspective, and suppose we travel in with a spacecraft which can overspeed, like escape the black hole, and we orbit as close to the event horizon, but the time is just like this. Suppose you travel one orbit around the black hole in like 8 minutes. The real world on Earth, suppose this is the Earth, the time on Earth would have been like a lots of years. So when you return back, you would be returning into the world of future. And that's all. Thank you for seeing my video, and hope you liked it, and hope it was educative.